again, this is Jay, your instructor for computer networks. In the last session, we have discussed the TCP/IP model and the OSI model. We also see the difference between the OSI and the TCP/IP. In this session, we are continuing for the physical layer and the transmission medium. So let's start. So the responsibility of the physical layer is that when the data is received from the data link layer, the physical layer will convert those bits into the signal and it will send using the transmission medium. And then after the signal will be converted to again bits and it will be delivered to the data link layer. You know that at the sender side, the flow of the data is top layer to bottom layer. So you can see that when the sender is sending data, at the sending side, the bits will be converted into signal. At the receiver side, those signals will be converted into bits and it will be delivered to upper layer. Now, there are two types of signals, digital signal and the analog signal. The digital signal has discrete voltage levels. For example, 0 volt for 0 bit and 1 volt for 1 bit. And the analog signal is a continuous in nature, means that the voltage level is continuously changing according to time. So there is a main difference between the digital and the analog signal. Both signals are electromagnetic signals. Now let's see what is transmission media. The transmission media is a physical media over which the communication takes place. Let's see the types of the transmission media. So there are mainly two types of transmission media, the guided and unguided. Guided means wired and unguided means wireless. The guided can be further categorized into three types, the twisted pair cable, the coaxial cable, and the fiber optic cable. And the example of the unguided communication is the free space. Let's discuss all. Let's see the twisted pair cable first. So the twisted pair cable is made of two plastic insulated copper wires which are twisted together. So you can see that this is the twisted pair cable and it can be seen in the Ethernet cable, the LAN cable that you use to connect your laptop or your router. So you can see in this figure two cables which are insulated by plastic are twisted together and it is simply called twisted pair cable. In the twisted pair cable, the signal is flowing is difference of these two cables. What I'm trying to say is, for example, the first cable is carrying 3 volt and the second cable is carrying 5 volt. So the actual signal that is being transmitted over the cable is difference of these two voltage levels and it will be 2 volt. Now suppose, for example, the first cable is carrying 3 volt and 5 volt again, but in this case the noise is added. So due to some environment changes, the noise is added and the value of the voltage in this cable becomes 4 volt and 6 volt. So 1 volt is added due to noise. But actually we are considering the difference of these two cables, so the difference remains same, which is 2 volts. So due to the noise there will be no change in the voltage transmission. So that is why the twisted pair is beneficial and it is more efficient to use twisted pair cables when there is environment which has very large amount of noise. Now let's see the types of twisted pair cables. There are two types of twisted pair cables, shielded twisted pair and unshielded twisted pair. You can see that the first cable is the unshielded twisted pair and the second one is shielded. So when the cables are shielded, it can take more noise. Okay, so signals which are flowing through the cables will be less affected by noise. The second type is the coaxial cable. There are two types of wires. The core wire lies in the center and it is enclosed in an insulating material. The second wire is wrapped around the insulating material and the whole cable is covered by plastic. So you can see in this figure, this is the coaxial cable. Then after the third type is the optical fiber cable. In the optical fiber cable, there are three main components. The first component is the light source. The second component is transmission medium. And the third component is a light detector. So you can see in this figure, this is the example of light source, which is nothing but a laser. So when the sender sends data, the data is actually in the form of bits. And to transmit the data, you have to convert those bits into some signal. So when the bits means the data is applied to this laser, the laser will keep blinking according to the rate of data and light will pass through the medium. In the optical fiber, the transmission medium is glass, which is denser than the air, and the receiver is the light detector, which converts the light signal into the bits. Now let's see the working principle of optical fiber. The optical fiber has the dense medium, which is glass, and the outside of the optical fiber is air, which is less dense medium. When the light is passed from the glass to air, it will be moved away from the normal, and this angle is less than the critical angle. When the light is passing from the dense medium to less dense medium at the critical angle, the light will follow the medium between these two mediums, means air and glass. That is called the critical angle. And the light is passing the angle more than critical angle, it will be reflected back, and which is called the total internal reflection. So this is the basic condition for the optical fiber communication. The light should be inserted the angle more than the critical angle, so that it will be reflected inside the fiber and light stays inside the fiber. Now let's see the types of modes. There are two types of mode, the single mode and multi-mode. The multi-mode is further divided into two types, that is step index and graded index. Now what is the meaning of single mode and multi-mode? Single mode means that type of fiber can propagate one particular wavelength only. But multi-mode means that type of fiber can propagate more than one wavelength. That is why it is called multi-mode. And multi-mode is divided into two types, step index and graded index. So in the step index, the refractive index of the glass is changed descriptively, and in the graded index, the refractive index of the glass is changed gradually. In this example, you can see that this is the example of the multimode. So more than one wavelength can transmit, more than one signal can transmit throughout the fiber, but the single mode, only one signal can propagate. After that, let's see what is unguided transmission, which is also called as wireless transmission. The wireless transmission is divided into three types. The first is radio wave, the second is microwave, and the third is infrared. You can see the range of 3 kilohertz to 330 kilohertz is for the communication of ships. After that, range of 300 kilohertz to 300 megahertz is for the communication of television, radio, and the mobile phone. And after that, 3 gigahertz to 300 gigahertz is for the communication of satellite, which is for microwave. Let's discuss all these types in detail. The first is the radio wave. The radio frequency has very large wavelength, so it can penetrate through walls. The radio frequency at the radio wave at the lower frequency can travel through walls, and at higher frequency it can be bounced back. But due to the large wavelength and due to the less intensity, to transmit the radio wave you cannot transmit directly. So to transmit the radio wave for the long distance, you have to do the modulation, and there are different type of modulation available. Now what is modulation? When we want to transmit lower frequency signal, they that type of signal cannot transmit long range. So what we do is we will modulate that signal for into higher frequency, so it can transmit for long distance. That is called modulation. There are different type of modulations: amplitude modulation, frequency modulation, phase modulation, etc. After that, there is microwave. Generally the frequency of the microwave is in gigahertz, and microwaves are used for satellite communication. The microwave can travel through straight line, and the sender and the receiver should be aligned so that communication can take place. So you can see the frequency of the signal is very high. And the last one is infrared, and infrared lies between the visible light spectrum and the microwave, and it is used for short range communication. So infrared receiver can be found in your remote, or it can be found on the surface temperature measure device. So this is it for today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.